And today we'll talk about basis, dimension, and linear transformation. There are three topics we will discuss today in a vector space. Now, the definition of basis. If S is equals to V1, V2, Vn is a set of vectors in a finite dimensional vector space V, then S is called a basis for V if it satisfies two conditions. The first one is when the set S is a span of V, it means S is a set span of V vectors. It means, and the second condition it is S is linearly independent. If there are two conditions, if it hold of any vectors, set of vectors, that's why it formed a basis. So now write an application about this trend. The first application we will discuss about the basis. Let V1 is equals to first vector, second vector, and third vector. Show that the set S is equals to V1, V2, V3. These are the vectors of the sets form a basis of R cube. R cube represent here three-dimensional vector space. So we will start. So first we solve it by span for span S. The first condition, first we will consider first for S span S, let X, Y, Z belong to R cube. A1, V1 plus A2, V2 plus A3, V3 equals to set of X, Y, Z. So student, A1, V1, it means there are three vectors. So we will write the vector equation A1, V1 plus A2, V2 plus A3, V3. Let X, Y, Z belonging R3 means which is equals to X, Y, Z. So according to condition, we write the vectors V1 plus A2 into V2. V2 is 290 plus A3. V3 is 334, which is equals to X, Y, Z. We formed an equation A1 multiplied by 1, A2 multiplied by 2, A3 multiplied by 3. So it means A1 plus 2 times of A2 plus 3 times of A3. The first expression, then the next one, we're multiplying by 9 by this. So 2A1 2A1 plus 9A2 plus 3 times of A3. The last expression it is A1 plus 4 times of A3, which is equals to X, Y, Z. So on equating left and right hand side, so the first equation it is A1 plus 2 times of A2 plus 3 times of A3, which is equals to X, and 2 times of A1 plus 9 times of A2 plus 3 times of A3, which is equals to Y, and the last one it is A1 plus 4 times of A3 is equals to Z. Now on equating left hand and right hand side, the expression formed an equations. There are three equations will be formed. Student, if we These equation, if it will be converted into coefficient matrix A, so write the coefficient 1, 2, 1, 2, 9, 0, and 3, 3, 4, and find the determinant value. 1 into, when we expand the column 1, so 9 4s are 36 minus 0 minus 2. When we consider this column, so we're multiplying 4 to the 8 minus 3 1s are 3 plus 3 times 0 minus 9, and find the result. It is 36 minus 6, 8 minus 3, it is 5, 5 minus 5 to the 10 minus 27. So 36 minus 37, which is equals to minus 1 and not equals to 0. So and agar if determinant of A not equals to 0, hence the solution is inconsistent. Hence the solution is inconsistent. This means span of S is equals to V x y z belongs to R cube. Now for the second part, for linearly independent. Solution is consistent, not inconsistent. Consistent. Hence the solution is consistent. For linearly independent, A1 V1 plus A2 V2 plus A3 V3 equals to 0. Since the determinant of value which is not equals to minus 1, which is not equals to 0, this means A1 A2, that is A1 A2 A3 is equals to 0. Hence the vectors are linearly independent. Hence the vectors are linearly independent. So therefore S is equals to V1 V2 V3 form a basis of R cube, because student, there are two conditions, both are satisfied. S is span B and S is linearly independent set. When the both conditions are satisfied, that's why we write here, right, the given vector space S is equals to V1 V2 V3 form a basis of R cube. Now the second application about basis. Student, find a basis for the set of vectors lying on the plane. Pi represent here x, y, z plane, and the equation of x, y, z plane 2x minus y plus 3z is equals to 0. Since pi is a vector space, since pi is a vector space, and if x, y, z belongs to pi implies that 2x minus y plus 3z is equals to 0 and y is equals to 2x plus 3z. This means that now x, y, z, which is equals to the value of y is equals to 2x plus 3z. The x, it means x, y, it means y. So, student, if we take common x, it means 1 to 0. If we take common y, it means sorry for that, z is z because value of y. So we will put here z. That means x and z both are present. Y is absent here. So if we take common z, it means 0, 3, 1. Hence, V1 is equals to 1 to 0. V2 is equals to 0, 3, 1. These are the vector space span pi. Since they are linearly independent, since they are linearly independent, so they form basis. So they form a basis for plane pi. These are the vectors. It means they form the basis. These are the basis, student. So V1, V2 is equals to span V. It means both span V. It means span pi. So since they are linearly independent, both are linearly independent. You find the determinant. If it is not equals to 0, it means so they form the basis for pi. Now for the second definition about dimension. What is dimension? The unique number of vectors in each basis for V is known as dimension of V. For example, student, if there are two vectors in a basis, so it means it has the dimension of vector space. It is the dimension of vector space. We call it dim of dimension of V. Dimension of R raised to the power n is equals to n. And dimension of Pn, P represent here the polynomial function. If Pn it is 3, Pn it is 2, it means 2 plus 1 is the dimension. Or when we consider the matrices, the dimension of matrices when m is number of rows and n is number of order, number of column. So the dimension of mn is equals to mn when multiplying both rows and column. For example, if it has 2 rows and 3 columns, so 2 3 is 6. The dimension of this matrix it is, for example, if number of rows are 2, number of columns are 3, so the dimension of this matrix it is 2 3 is 6 according to the definition. And the dimension of a span of the vectors v1, v2, vn, which is equals to r. R means rank. R represent here the dimension of span vectors, right? So now write an application about dimension, student. Find a basis and dimension of the given equations. Here, if we convert these equation into matrix, the coefficient of x is 1, the coefficient of x is 2, the coefficient of x is, if we write as, the coefficient of y is 2 minus 1, the coefficient of z is minus 1, and it is 3. The matrix, since A is equals to 2 by 2, 3, 2 by 3 matrix, therefore, S is a subspace. S is a subspace of R3, three-dimensional vector space. So here we are applying the row operation, student. Do you know about the row operation? It means first row as it is, and we write here 0, 0. So 2 minus 1 of 3. In the next step, we will applying the row operation. First row as it is, minus 2 multiplied by R1 plus R2. It means change in R2. So it means minus 2 plus 2, it is 0. Minus 2 to the 4, minus 1, minus 5. Minus minus plus 2 ones are 2. 2 plus 3, it is 5. And 2, 0, 0. Student, if we divide it multiplying by 1 upon 5, or if we write here minus 1 upon 5 of R2, change in R2, means first row as it is, 0, 1, minus 1, 0. So in the next step, student, to reduce echelon form, so if we multiplying by minus 2 R2 plus R1 in this step, so it means first we write the second row as it is, and 0, 1 as it is, minus 2 multiplied by 1, it is, then add plus 2, it means 0. Minus minus plus 2, minus 1, it means 1, and it is 0. So student, after that, it will be reduced in reduced echelon form, the given matrix. Then we formed an equation. If we write the variable x, y, z, so the first equation is x plus z is equals to 0, and y minus z is equals to 0. So it means x is equals to z minus z, and y is equals to z. It means z is equals to z. So therefore, x, y, z, which is equals to x is minus z, y is z, and z is z, it means if we take in common z, so it means minus 1, 1, 1. So it means there is only one vector. This is a vector. That's why v1 is equals to minus 1, 1. So dimension of vector is space. It is 1. This will be answer. Now the second application about the dimension is to find a basis, find a basis find a basis and dimension of the polynomial function P3 represent here three dimensional polynomials 3x cube minus 4x plus 6x square. So student, as we know that the power x is 0, the power x is 1 and x is 2. So there are three powers 0, 1, 2. X1, X2. It means when we consider the power, it is 3. So x cube minus 4x. So we will consider the power, it is x1, x2 and x3. The coefficient of x is 1. In this form, I have missed my problem. We now write another application about the basis and dimension, student. Determine, find a basis and dimension, find basis and dimension find the basis and dimension of the following 2x minus y plus 3z is equals to 0, 4x minus 2y plus 3z is equals to 0, minus 6x plus 3y minus 9z is equals to 0. So student, first we make a coefficient matrix. The coefficient of x is 2, If we write here, in this column, x is 2, x is 4. In the first column, it is minus 6, and it is minus 1, minus 2, 3, and the coefficient of z is 3, 3, minus 9. So this is called the coefficient matrix, and write the name, it is A. When we have determined the value of A, or when we are applying the operations, the first operation, it is minus 2 of R1 plus R2 is equals to R2. And the second operation, it is the 3R1 plus R3 change in R3. So it means first row as it is, and if we write in this form, because it is homogeneous equation, so we write the equation, it is in homogeneous equation. So minus 2 times of R1 plus R2 change in R2, 3 times of R1 plus R3 change in R3. So student, we will solve in this way. First row as it is. When we multiplying minus 2 to the 4 plus 4, it is 0. Minus minus plus 2, 2 minus 2, it is 0. Minus 2, 3 is 6 plus 3, it is minus 3. It has 4, 6y, because I have missed this value, it is 6. The second equations are, again we see there, I have missed something. The first equation is 2x minus y plus 3z, 4x minus 2y plus 6z. So there are, it has mistake. I have a mistake. It is 6z and minus 6x plus 3y plus 3y. It is minus 9z. So we will simplifying them. So coefficient of y is minus 1, minus 2, and 3. And coefficient of z is 3, 6, and minus 9. Thank you. So when we applying the operation, student, 2, 3 are 6, it means 6 plus 6, it is 0. And 0 as it is. So when we multiplying, first row multiplying by 3, 3 to the 6 minus 6, it is 0. And minus 3 plus 3, it is 0. And 3, 3 is 9, minus 3, 9. 3 is 9, minus 9, it is 0. It means the first equation, if you write in this way, 2x minus y plus 3z is equals to 0, if we find the value of y, 2x plus 3z, it means the single equation, the single equation 2x minus y, the single equation 2x minus 3y, 2x minus y plus 3z is equals to 0. S is a plane, it means so therefore y is equals to 2x plus 3z and x is equals to x and z is equals to z. This means if we write x, y, z, which is equals to x, 2x plus 3z and z is equals to z. So if we take in common x 1 to 0 plus z, if we take in common, so it means 0, 3, 1, the coefficient of z. If we write it here, so there are two vectors v1 and v2. So the dimension, these are the vectors represent here basis. So there are two vectors formed a basis. So the dimension of vectors, hence the dimension of S is equals to 2. These are the bases. So find the basis and dimension. The dimension of, there are two vectors only. So the dimension of S is, it is 2 of the given vector S. Now student, what is linear transformation? Let V and W be the two vectors space with the vector space. If T mapping V into W is a mapping from a vector space V to W, then T is called a linear transformation from V to W if and only if when it holds these two properties, T of transformation of U plus V is equals to T of transformation of U plus transformation of V, and the second property it is transformation of K times of U, which is equals to K times of transformation of U, where K is any scalar value. So if you see that there are two vectors U and V, if V has three elements U, V and U plus V, so the transformation of U into V, we call it transformation T of U, T of V and T of U plus V. What is zero transformation? Let V and W be any two vector spaces. The mapping T map V into W such that T of V is equals to 0 for every V in V is a linear transformation. This type of transformation is called a zero transformation. For example, transformation of U plus V, which is equals to transformation of U plus TV. If the transformation of V is 0, it means transformation of U and V both are 0. So the transformation of U plus V, which is equals to 0. Similarly, if the transformation of K times of U, if U is 0, for example, so K times of T of U, it is 0, 0 dot K, it is 0. The transformation of KU, it should be 0. So this type of transformation is called a zero transformation according to definition. So now we consider two applications about the transformation. T of xy, let T mapping two-dimensional to three-dimensional, R2 to R3 be defined by transformation of xy, which is equals to x plus y, x minus y of 3y, to determine whether the given transformation from V to W, it is linear or non-linear. If student, there are two properties of linear transformation. If it hold, that's why we call it is linear, otherwise it is non-linear. So start now. Transformation of u plus v, which is equals to transformation of u plus transformation of v. First property. Now when we applying the first condition and u represent here x1, y1, we represent here x2, y2, for example. So therefore, T of u plus v means x1, y1 plus x2, y2, which is equals to transformation of u. Both are added. It means if we added both of them, so x1 plus x2 subtracted, it means x1 minus t times of x1 plus y1 according to the definition. Then when we remove the transformation, then it means when we applying this condition is when x plus y, it means if we added both of them, so x1 plus x2 plus y1 plus y2, both are x and y. If we consider according to the linear transformation, x1 plus x2 minus y1 minus y2 of 3 times of y1 plus 3 times of y2. So the first step of linear transformation, T of u plus v, T of u plus T of v, when we added both of them, so transformation of x1 plus x2 and v1, y1 plus y2, then we applying the transformation like as given transformation, it is x plus y, x minus y, 3y. So we put here, it is in similar way. So it is x plus y, x plus y, x minus y, and 3y1 means y1 plus y2. So in the next step, student, if we separate in this way, right, it means x1 plus y1 x1 minus y1 and 3 times of y1 . So it means x1 plus y1, x1 minus y1 of 3 times of y1 when you separate both terms in this form. U and v plus x1, x2 plus y2, x2 minus y2 and 3 times of y2. So student, this is called transformation of u. This is called transformation of v. Hence prove the transformation of u plus v, which is equals to transformation of u plus transformation of V. Now the second property it is transformation of K times of U, which is equals to K times of transformation of U. Now we applying the second property and we check them. So student, if we consider transformation of X is U is XY, which is equals to K times of if you multiplying together student T times of K of X, K of Y, if you multiplying both of them from K, so it is T times of K of X, K of Y. If we applying the transformation according to given condition, K times of X plus K times of Y plus K times of X minus K times of Y, according to the transformation 3 times of KY. It means if we take common instant from whole vector, so it means X plus Y, X minus Y, and 3Y, which is called transformation of U. So hence transformation of K of U, which is equals to transformation K times of transformation of U. Hence both properties are hold. So T is a linear transformation. Hence T is a linear transformation. T is an operator, student. Now the second application about the linear transformation. Let T be a linear transformation from 3-dimensional to 2-dimensional. These are constant values, student. If T of 1, 0, 0, which is equals to 2 of 3, T of 0, 1, 0, it is minus 1, 4, and T of 0, 0, 1, it is 5 minus 3, and compute them, then compute the transformation of 3 minus 4, 5, according to linear transformation. Student, we will start now. We have the transformation 3 minus 4 of 5. If we write in this way, student, if we take common 3, so it means 1, 0, 0 plus minus we will use in this way, student. 1, 0 minus 4. Suppose it is 0, 1, 0, where 4 lies in second row. It means all these elements are 0. Then we consider 5. It means 0, 0, 1. So these are the basic vectors. If we applying the operator T, applying operator T on both sides, it means T of 3 minus 4, 5, which is equals to 3 times of T 1, 0, 0 minus 4 times of T 0, 1, 0 plus 5 times of T 0, 0, 1. According to given condition, student, the first value it is T1, 0, 0, it is 2, 3. So applying the condition and we put here 2, 3, 2, 3 for the first, and T0, 1, 0 it is minus 4 into minus 1 4 plus sign 5 T001, it is equals to 5 minus 3. So all these values stand when we are applying the operators. So we put here these values according to the definition, then simplifying them. So student, 3 multiplied by each column vector, 3 to the 6, 3 3 to the 9, minus 4. If we consider minus minus plus 4, 4 for the 16 minus plus 5, 5 multiplied by 5, it is 25, it is minus 15. The student, so when we simplifying them, student, plus 5 5 is 25 minus 15 and add 6 plus 9, so if we put here, student, plus 5 25 minus 15 and simplifying them, 6 plus 4 plus 25, 9 minus 16 minus 15. If we add, so the answer it is 6 plus 4, it is 10, 10 plus 25, it is 35, minus 31 plus 9, it means it is 22. So the linear transformation we compute according to the definition of linear operator. So we will find easily with the help of calculator. तो स्टूडेंट हमने इसमें सबसे पहले क्या किया, मैं आपको एक्सप्लेन कर दूं. सबसे पहले हमने क्या किया, इस वेक्टर को कॉपी किया 3 minus 4 5, इसको हमने ब्रेक किया. If we consider the first row, so it means all these elements it should be 0. Then minus 4 when we consider, so 0 0 and 4 when we consider the second row, it means second row element it is present and the first and the last one value it is 0. And when we consider 5, so it means 0 0 1. After that descent, we are applying operator T on both sides. So we are applying operator and T100 it is T100 it is 2 3 and T010 it is minus 1 4 and T001 it is 5 minus 3. So we put all these values of the value. Applying this property in the given question. So we put here that because the linear transformation of this one which is equals to this, and after that we multiplying 3 of each element of the column vector, 3 to the 6, 3 to the 9, minus minus plus 4, 4 to the 16 minus, we take common positive, 5 has the 25, 5 3 the 15, and we add column and first row, all elements added of first row and second row. After that the answer it is 35 minus 22. So this is called the linear transformation according to the given condition. So thank you very much, student. I hope you will learn about this. I have completed my lecture. So thank you very much. Take care. God bless you. Allah Hafiz.